Today we are going to be looking at graphing motion, particularly on position time graphs. What position time graphs are basically are a way of us marking where an object is and where it moves to over time. So let's start with the axes. We'll just use a generic one right now with position on the vertical axis because that is the um, dependent variable. The position is going to change as a function of time. And on the horizontal axis, we'll put time. Here we have a bicycle. We'll call the right the positive direction and left the negative direction. So here we've drawn in a position time graph demonstrating the bike's motion. Notice that the position, the vertical axis, is what represents where the bike is at the moment. So in the beginning, if we go all the way to the left side of the graph, right in the beginning, the position of the bicycle is at 0. The bicycle starts at 0. As time moves forward, the position of the bicycle goes up, right? Which means it's moving in the positive direction, which for our bicycle is to the right. So over time, the position increases, which means it moves to the right. It moves at a constant rate. This is the same graph you should have produced from the Tumble Buggy lab. So we can see the velocity of the bicycle in the slope of the graph. In fact, that's going to pop up here in a second. Um, the slope of the graph always, of a position time graph, always represents the velocity of the object. Here we have a constant slope, and therefore we have a constant velocity. We have a positive slope, therefore we have a positive velocity. And in this case, positive means to the right. Let's look at a different one. Now, do we have a constant velocity? Yes, because the slope is constant. And remember, the slope is the velocity. This time, though, the velocity is negative. If we were to get the slope of this line, we would end up with a negative number. And a negative velocity in this context means the bicycle is moving to the left. Notice that the bicycle on the graph starts far away from 0, but as time moves forward, it goes closer and closer to 0. That again would be negative motion. All right, now we have a horizontal line. In a horizontal line, the bicycle is at, let's say, 20 meters, and then an hour later, it's still at 20 meters, and an hour later, it's still at 20 meters. It's not moving at all. Its position remains constant as time moves forward. Remember, position is shown on that vertical axis, and because the line doesn't change vertically, position is not changing. Another way you can see this is by looking at the slope. The slope of this line is 0, therefore the velocity is 0, therefore the bicycle is not moving. Let's do a couple practice examples. Bus driving at 40 kilometers an hour to the east for 20 minutes, then stops for 5 minutes, then drives 50 kilometers an hour to the west for 10 minutes. And you draw the graph. The first thing we're going to do is look at that first period of time. 40 kilometers an hour for 20 minutes means there should be an upward sloping graph for the first 20 minutes. And we can see that here. An upward sloping graph. Then it's at rest for 5 minutes. It stops for 5 minutes. Then it drives back to the west, meaning it must have a negative slope, and we can see the negative slope on the right-hand side. Now we want to describe the motion of the ladybug shown in the graph below. For the first 10 seconds, what is the ladybug doing? The ladybug is staying at 4 meters. So constant 4 meters for the first 10 seconds. Then from 10 to 15 seconds, it's moving in the negative direction because it has a negative slope. And it's moving fairly quickly because the slope is steep, and the steeper the slope, the faster. From 15 to 25 seconds, it's moving in the positive direction. And finally, it rests from 25 to 35 seconds at 2 meters, not moving at all. Let's look at some position time data. Here I've given you the position and time data the same way that I might on an exam or a quiz. Graph the data on the position time graph and compare the average velocity of each car. So here we've plotted out the velocity of each car using the position time graphs. You can see that car B has a constant slope, and car A has a slightly increasing slope. Which one is moving at a constant velocity? That would be B. B is moving at constant velocity because its slope is constant. A is accelerating, it's getting faster and faster because that slope is becoming steeper and steeper. That means the slope is becoming a bigger number, and since velocity is slope, that means the velocity is becoming a bigger number. And that is it for the PowerPoint. We're going to jump now to looking at some written examples. What is happening in this graph? We have a constant positive slope. So this means constant velocity. We can also write positive. That's because it's moving from around 0 to around, I don't know, we could make 100 meters up here or something like that. And as time goes on, it moves further and further towards the 100 meters at a constant rate. Let's look at the second one here. The object moves in the positive direction at a constant speed, and then it's at rest. So wherever it made it to, it's like it walked across the room and then sat down on a couch. And in this time, it is not moving. And then at some point, it gets up and it moves in the opposite direction. And it ends up where it started. How do we know? Because the vertical axis gives us our position, and our final position is the same as our initial position. Let's look at this one. Where does the object start? Does it start at 0? No, it starts far from 0. It could start down the street, or across the house, or on the other side of the field, right? This could be a football field with this being our end zone and this being the opponent's end zone. What happens over time is the ball is moved from the opponent's end zone towards our end zone. But then the player is tackled and the ball is at rest because there was a penalty or because there needs to be a replay or something or a commercial break, even better. One of the red hats gets out on the field and the ball sits still for several seconds. And then the next play happens, and once again, the player drives the ball forward at a constant rate towards our end zone. Hopefully this is not actually our end zone, because that would be 2 plays moving across the entire football field, and that would mean our defense is awful. Next, we have a horizontal line. Horizontal line means the object is here, and later it's still here, and later it's still here. meaning the object is at rest or not moving. Just a reminder, if it's hard for you to visualize what's happening here, we can call this a negative side and this a positive side. This vertical area is our position. So we could imagine it as here's my house and here's your house. And you have such a big house. And this is the road in between. So what's happening when we have a position time graph, let's say you start here and move here. What you're actually doing is you are walking towards my house. And this horizontal area is really just showing the time. So you make it here at this time, let's say 30 seconds in. And maybe you turn around and walk back. And this would be maybe 45 seconds. And you make it back to your house at around 45 seconds. Notice that you had to go faster to get back in the same in a less period of time. So hopefully that makes sense. Hopefully you're starting to see position time graphs. Remember to look back at your Tumble Buggy lab and maybe also at that Roomba recording.